As we know, hello dear students, as we have started chapter number 4, that is unit 4 on analysis and design of slabs. In that we have gone through some initial theory regarding slab, introduction to slab, different types of slab and all. So in this lecture we will discuss about design steps, how to design a one-way slab. Okay. So first of all, as we know, in designing of slab, we'll consider a 1 meter strip, because while designing a beam, we know the width is defined. Okay, cross-sectional dimensions of beam are very less or negligible as compared to its length. और बीम के अंदर हमको क्या होता है, उसकी विड्थ और डेप्थ, और इनिशियली विड्थ उसकी हमको डिफाइन होती है, लेकिन स्लैब डिज़ाइन करने के लिए हमको थ्रू आउट द स्पैन, पूरे पैनल के लिए, पूरे रूम के लिए और पूरे फ्लोर के लिए हमको डिज़ाइन करना होता है. तो उतना बड़ा डिज़ाइन करने के बजाय हम क्या करेंगे, यहाँ पर 1 मीटर की स्ट्रिप एज्यूम करेंगे एज ए विड्थ, एंड वो डिज़ाइन पूरे स्लैब के लिए हम अप्लाई करेंगे. ओके, तो फर्स्ट ऑफ ऑल, फर्स्ट स्टेप इन डिज़ाइनिंग ऑफ वन वे स्लैब इज we will select the preliminary depth, that is initial depth, by using the span to depth ratio, and this span to depth ratio ranges in between 25 to 30 for simply supported slabs. As you know, the span to depth ratio is given in IS 456. Okay, so in that the basic values are given for beams, that is for simply supported beam, for continuous beam, and for cantilever beam if such beams are having spans not exceeding 10 मीटर. 10 मीटर से ज़्यादा अगर से स्पैन एक्सीड नहीं हो रहा है तो उसके लिए बेसिक वैल्यू दी हुई है. सिंपली सपोर्टेड के लिए 20, कंटिन्यूस के लिए 26 और कैंटिलीवर के लिए 7. व्हाट अबाउट स्लैब? तो स्लैब के अंदर एक सॉलिड पोर्शन के लिए, एक आपको शीट के लिए और एक थिन लेयर के लिए आपको क्या है, डिज़ाइन करना है. ठीक है, इसकी विड्थ क्या है, ज़्यादा है, और शेल पोर्शन है स्लैब. ठीक है, तो इसके लिए हम क्या करेंगे, जो भी डेप्थ मिल रही है और जो भी रेशियो मिल रहा है उसको मॉडिफाई करेंगे. जो बेसिक वैल्यू आपको बीम के लिए यूज़ कर रहे थे उसको आप मॉडिफाई करेंगे बाय यूजिंग सम मॉडिफिकेशन फैक्टर, एंड दैट फैक्टर इज डिपेंड्स ऑन परसेंटेज ऑफ स्टील and area of steel we are going to provide, as well as the grade of steel we are using. Okay, so these values are given in figure number 4 of your IS 456, which is on page number 38 for the tensile reinforcement. In that, two values we have to remember. That graph is given for the different FS values, different stresses. That FS depends on your yield stress of reinforcement and the area of reinforcement we are going to provide. Okay, so you can refer that graph on your IS 456 page number 30. You can see on your slide. So this graph we will use for selecting the initial depth by assuming some percentage of steel. Now second step is calculation of bending moment and shear force, that is maximum bending moment and maximum shear force that the slab is going to take, or that much amount of movement and shear force is going to induced on that slab portion by the external loading. For calculating such movement and shear force, we will use shorter span. Generally, in case of one-way slab, we will design for the shorter span. We will consider bending in the shorter direction, and we will provide main reinforcement in the shorter direction. Okay. Now third step is we will check our initial depth with respect to bending. That is, we will check the minimum depth required for the bending criteria. For that purpose, we will equate the maximum bending moment, जो भी आपकी maximum bending moment second step में मिल रही है, उसको हम equate करेंगे limiting bending moment से, that is MU limited, which we have already studied. That depends on the different grades of materials. That is values of FCK एंड Fy. ओके, दोनों को इक्वेट करेंगे, वहाँ पर डेप्थ अननोन रखेंगे हम, विड्थ 1000 लेंगे और जो भी डेप्थ आ रही है रिक्वायर्ड बेंडिंग के लिए उसको क्रॉस चेक करेंगे इनिशियल फर्स्ट स्टेप की डेप्थ से. इफ़ दैट डेप्थ रिक्वायर्ड इज लेस देन आवर provided depth, then it is safe in the bending. Now next step is calculation of reinforcement for the slab per meter width of the slab. For this purpose we will use the formula AST equals to 0.5 FCK divided by phi in bracket 1 minus under root of 1 minus 4.6 mu divided by FCK BD square whole bracket into BD. This equation we will use for the calculation of main reinforcement. Now next step is calculation of spacing required by assuming some diameter of the bar. Now this diameter of bar should not exceed the 1/8 of the overall thickness. This criteria is given in your IS 456. Now next step is calculation of distribution reinforcement. Now here we should remember the purpose of distribution reinforcement is to evenly transfer the load and stresses towards the main reinforcement. इसका मेन पर्पस क्या है? मेन बार्स को और मेन reinforcement को होल्ड कर रखना और जो भी स्ट्रेसेस और लोड आ रहा है उसको इवनली मेन reinforcement में ट्रांसफर. इसका कुछ पर्पस ये नहीं है कि कुछ लोड ये कैरी करे. ओके, तो इसके लिए हम डिस्ट्रीब्यूशन reinforcement मिनिमम क्राइटेरिया के लिए डिज़ाइन करेंगे. दैट इज दिस ASTD विल बी इक्वल्स टू द मिनिमम reinforcement रिक्वायर्ड फॉर द स्लैब. नाउ मिनिमम reinforcement रिक्वायर्ड फॉर द स्लैब इज 0.12% and 0.15% of gross dimension of the selected portion of slab. That means 0.12% is for the HYSD bars. If we are using HYSD bars or grades of steel as a FE 4 and 5 and higher grade, then we will take minimum reinforcement as a 0.12% of gross cross-sectional area of the slab. That is 1 meter strip B multiplied by overall depth capital D, and 0.15% of gross cross-sectional area for the mild steel. After calculating ASTD, that is distribution reinforcement, will find the spacing required. Okay, then these both spacing will check as per the IS requirement. Okay, now next step is we will check the our design depth for the deflection purpose. जो डेप्थ हमने फर्स्ट स्टेप में निकाले उसको हमने थर्ड स्टेप में क्या किए? बेंडिंग के लिए चेक किए. ओके, बेंडिंग में सेफ आ गया है वो. उसके बाद हमने reinforcement निकाल लिए. नाउ आफ्टर गेटिंग द AST and after providing some spacing we will get the AST provided, and for that AST provided we will find the percentage of steel we are providing. Based on that our actual percentage of steel we will again check the depth for deflection, same as we have did in step number 1. The next step we will check the depth for the shear. Generally slab will be safe in shear in all the cases. Now for this purpose we will refer clause number 40.2.1.1 of your IS 456. Now there is slight change in the check of shear is that we will not use the direct values obtained from the table for design shear stress. जैसा कि हमको मालूम है टेबल नंबर 19 के अंदर हमको डिज़ाइन shear stress that is tau c के वैल्यूज़ दिए हुए हैं. किसके ऊपर डिपेंड करते हो? दैट इज डिपेंड्स ऑन percentage of steel and grade of concrete. Those values are for beams, but for slab, for the solid portion of slab, those values will be modified by some multiplying factor, that is K. Now this K is depends on the overall thickness of the slab. Okay, so based on thickness we will find the value of K by using IS 456, and that value will be multiplied to the actual tau c which we are going to obtain from the table number 19, page number 73 of your IS 456, that u the tau c dash for our slab. That tau c dash should be less than tau v, that is nominal shear stress. Okay, but usually this tau c dash will be always less than your tau v. Next step is In some cases we have to check the development length. That is for generally for continuous slabs we have to go for the check of development length. Same as we have did in the design of beam. That is, we will check the actual LD required. That is, LD equals to what? 0.87 Fi into phi, that is diameter of reinforcement, divided by 4 times tau PD. That tau PD depends on again grades of concrete. Okay, that LD should be less than or equals to 1.3 times M1 divided by V, that is shear force at the support, plus L0. That L0 will be based on the diameter of reinforcement, 12 times phi or effective depth. दोनों में जो लेस रहेगा वो हम L0 की वैल्यू लेंगे. Okay, now by using this step we can easily design a one-way slab. Hope you have understood these steps very well.